Hello.
Hello. Oh, on a scale of 1 to 10, I look absolutely terrible.
All right. Where are we at?
I just emailed you my assignment,
Okay.
but number 6 didn't extend at all. I left number 6 blank.
Okay. Are you sending it using pictures?
Yeah.
Okay.
But number 6, like, really, there's nothing like it in the book. I think, like, the P in it, I think the P should be, like, a sign or codes or tab.
No. This is what this means. And there are questions like that in the book.
Oh, I didn't. Okay, then I missed that. Can I do that question again and then hand it in?
Okay. I need you to do something else. Oh. I want you. Well, hi, Mary. I would like you to try and send it as a PDF rather than pictures, because I have to print the individual pictures off, and it causes a bit of grief. So.
Okay, then I'll resend that.
Okay, so if you can do that. I'm trying to get my.
Ignore that email I sent you.
Okay, because I just printed it, so that's fine. All right.
Mr. Newton, I'm trying to send us a PDF, but I'm having trouble, so I'm gonna go back on it and see. I'll research what's best. I'll try and go with Google. Normally they're pretty good.
Well,
I can do a draw. Get a PDF, but it takes a while to load.
Yeah, there's an app. It's called PDF Lite, which allows you to use your camera and it'll convert it for you.
PDF.
Yeah.
Okay. I'll download that.
Okay.
Okay.
PDF Lite.
Yeah.
Okay, I'll read that question and then I'll send it as a PDF.
Okay.
Yeah, I'll try and download that and see if that works. If nothing else is gonna work.
Yeah, if I can get these all as PDFs, that makes things a lot easier. The pictures are just not showing up properly, and they're different sizing than all of them. So, okay. Basically, what you need to do today is go through that review. All right. Although I don't imagine you're finished 6.4 in its entirety, which would be something I think is necessary for you to do. So let's kind of look at 6.4 today, and then look at the review and go through it. And then we'll take today and tomorrow to finish up this chapter 6. And then on Wednesday, likely Wednesday, I'll start chapter 7 with you. We've already done exponential functions in applied, so it's not a big deal if we take an extra day or two on this trig before we get into the exponential functions. So we could do this as, maybe let's finish up chapter 6 by the end of the day, Wednesday. Let's do that. Okay. All right. Are there any? Yeah.
I can't see anybody.
Okay. Well, we can see you.
Yeah.
Camera off. I have to turn the camera off in order to see people.
Okay. So basically,
I can't see the board at all. That's my issue. I'm just gonna exit and rejoin.
okay. And then mute, and then we'll go from there. Okay, so if everybody wants to mute their mics until it's time to speak here. Just looking back into that 6.4, are there questions in there that you want to see done? Like that's an extensive one. That's an important one. So I would make sure that we can do that because I did skip 6.3. So you've got to know how to do 6.4 well. All right. Does anybody want to look at any of the questions in 6.4 right now? Does that mean that nobody's done it or you're doing all right?
I'm just working through mine slowly. Like,
okay, well,
taking the question, but I do it.
Okay, yeah. Like, I'm not saying you have to do every question, but you certainly have to get through this. Like question 5, 6, and 7, question 4, those are all extremely important questions. And if you're doing a provincial exam, I guarantee 2 of those questions will be on that exam. All right. Excuse me. Let's go through. I'm going to go through 3A, 4A, 5A, 6A, 7A. That might be the best way to go about this. Okay, so start on page 219. Okay, so first thing that we do, once we've got it equal to 0, we factor it. So I've got sine x minus 1 equals 0. Sine x is equal to 0. Sine x is equal to 1. Okay, so then I go back to using my unit circle. It wants it between 0 and 2 pi. So all I have to do is go around the circle 1 time. So where does sine x equal 0? 0.
And pi.
And pi. And where does sine x equal 1?
0. Or no, sine x is equal to 1. Is that pi over 2?
Yeah. There's my solution. Okay, so that's a very basic question. It uses the unit circle, so you don't have a lot to do other than know what that unit circle is. Okay. All right. Let's have a look at 4A now. Sine 2x minus 1 equals cos 2x. So that first example we did, something we've already done in that third unit. So now we're going to use the example on the board. Now, all that does is that takes into account my identities now. So I want to switch these identities. It says solve each equation algebraically. So this one goes to 2 sine x cos x minus 1 equals. Now you have your choice of 3. So it doesn't matter which one you use for any of the 3, but I'm going to use 2 cos squared x subtract 1. That's the first one. Okay, now I get everything to one side. So I'm going to move this over to here. So I get 0 is equal to 2 cos squared x subtract 2 sine x cos x. And when I add the 1 to both sides, I get 0. So this is what I'm left with. So now I'm left with 2 cos squared x minus 2 sine x cos x. Again, because it's equal to 0, I can factor this. Oh, this did not
I
work
can't
out as.
really see the board.
Hold on. Don't think that worked out as planned. Actually, it did. It did. It kind of worked out where I wanted. Okay, 2 cos x. I'm going to factor it out, and it's going to leave me a cos x minus sine x. Okay, so this one's interesting for us. So we got 2 cos x equals 0, so that means where cos x is equal to 0. That's easy enough. All right, that happens at pi over 2 and 3 pi over 2. Okay, so that one's fine. Now, this guy is cos x minus sine x equals 0. Where does cos x equal sine x?
Square root or pi over 4.
Yeah.
And where else is tan? And then 5 pi over 4.
Right. So there's your solution. Pi over 2, 3 pi over 2, pi over 4, 5 pi over 4.
Can I ask a question?
Yeah, absolutely.
Back to the beginning, where did you find the identity?
Okay.
Like that?
Yeah. So this is one of the things that I kind of mentioned to you to do is create an identity sheet for yourself. All right. So Mary, do you have your book in front of you, Mary?
I have one right from the exam.
Okay. So look on that exam one, right?
Yeah.
And there is only one for sine 2x. There's only one identity. Sine 2x is 2 sine x cos x. Okay?
Okay. Yeah.
And then cos 2x, you have 3 choices for it.
Okay.
And so you pick the one that makes the question the easiest for yourself.
Okay.
All right? So in this question, it didn't matter, to be honest with you, Mary. I could have used any of those 3 and still ended up getting the same answer, and with about the same amount of work. So I just took the 2 cos squared x minus 1 and did it.
Okay.
Okay? Just 1 second. All right. Mary, does that make sense to you? Are you okay with that?
Yeah, that's fine. I got it.
Okay, so let's look at 5A now on page 220. Sine squared x sine squared x minus cos squared x equals 1/2. All right. Okay, now normally the first thing I would tell you to do is get it equal to 0. So I'll subtract 1/2. But I think what I'm going to do instead is, again, it's tough to work with these questions when I have sine and cos. So I'm going to convert them. So this is the one that happens often. You need to remember this guy all the time, and that is this. Use cos squared theta plus sine squared theta equals 1. That's Pythagorean identity. So I'm going to use it to change one of these two. Okay, now it doesn't matter which one I use. So I'm going to substitute in for sine squared. So I'm going to make that 1 minus cos squared x. like that. Excuse me.
Thanks you.
Thank you. Okay, so I have, so what I did is I arranged this. I made that sine squared equals 1 minus cos squared, and I substituted it in. So now I have 1 minus 2 cos squared x equals 1/2. All right. Again, the best thing that I can do is change them so that they're all the same. I'm going to subtract 1. And then I'm going to divide or multiply. I'm going to divide by -2 or times by -1/2. So I'm going to end up with this. Cos squared x equals 1/4. So I times this by -1/2. I times this by -1/2, and I get that to 1/4. All right. So what's the next option now that I've got it to here? How do I get cos x? How do I get rid of the squared value? How do I ever get rid of a squared value?
Square root it.
Right. So I'm going to end up with cos x equals plus minus 1/2. Square root of 1 is 1. Square root of 4 is 2. I have to take the circle. Does the cos x value equal 1/2 going around your circle, or -1/2?
4 pi over 3.
Okay.
2 pi over 3.
Yeah.
Pi over 3.
Yeah.
And 5 pi over 3.
That's right. There you have it.
Could you move your phone, maybe?
Which way?
Like a hamburger, or yeah, like a hamburger.
What?
Like turn it sideways.
Let me do that.
That?
Yeah, that's good, thank
What
you.
does that have to do with a hamburger? Okay.
I can't see anything, Mr. I can't see your screen.
Oh, it's because he hasn't talked.
Okay.
Oh,
So everybody else put on mute. So I'm the last guy you hear. Mary, just give me a thumbs up if you can hear and see now. Okay. All right. So we're okay. I'll look at 6A now. All right, so factoring again, we're going to factor the values of 8 that give me -6. So again, I'm going to use the advanced way of doing it. So 4 times 2 gives me 8. 4 times 1 is -4. -1 times 2 is -2. That gives me -6. -1 and -1 give me plus. So now here's what I have. Sine x equals 1/4. Sine x equals 1/2. Well, you work with the unit circle first, where sine x equals 1/2. So that's, and it's radians still. So pi over 6 and 5 pi over 6. Okay. And then over here, I have to work with my calculator, change the mode to radian. Second sine, 0.25. So my reference angle is in quadrant 1, and sine is equal to 1/4 at 0.25268. And then in quadrant 2, $2.889. So your solutions are 0.25268 and 2.8889, and pi over 6 and 5 pi over 6. Okay. So this one takes into account your unit circle, plus it takes into account the fact that you have to do use your calculator for it. All right. That number 6, A, B, C, D, E, and F, you want to spend some quality time on those and make sure you do all of 6 for sure. Okay. All right. So,
Mr. Newton,
yeah.
when you punch into your calculator, like for like quadrant A and quadrant 2 there,
Yeah.
what are your calculator functions? Because I'm not getting that. What are your steps?
Second sine 0.25.
Oh yeah, I did sign. I forgot to put second function.
Okay.
Yeah.
All right.
Yeah.
Okay. So that's all I have right now for material for the pre-calculus class. Is there anything else in there that you want to look at this morning? Because basically what I'm doing is I'm going to leave this with you for another day or two. Do 6-4 today. Start your review tomorrow, or 6-4. Finish it today and tomorrow. Start your review. Get it done Wednesday, and then we'll start new on Thursday or Friday on that exponential. But that's all I want to do right now for pre-calculus. I do want to do some physics questions with you. So is there anything, before I go to physics, anything else on pre-calculus you want to ask, discuss, need to see?
Like number 7 on page 225.
Yeah. Okay.
So like I figured out my sine ratios and everything. I got like my triangle, my x is 24, my y is 7, and my r is 25.
Yep.
And then I just plugged those in for like my double identity. Like I got the 2 sine
Yep.
x cos x whatever.
Yes.
But then figure out like the value.
That
Is
is-
it just, do you have to add the fractions? Do you have to multiply the fractions? Like what do you do?
It's multiply. There's no add signs in that identity. It's just multiply, multiply.
So I just multiply everything across the top and everything across the bottom?
Yeah.
Okay.
Yeah. Let me do that question just because it's a question that you would see as well. It's a guaranteed question on the exam. So draw my triangle in quadrant 2. Theta is always right there to draw the triangle. Pardon me?
That's in quadrant 3, not quadrant 2. Oh wait, no, never mind. I'm thinking of the cast thing.
Okay, you're okay?
That's my bad.
All right,
Sorry.
that's okay. So now I have 7/25 here, right? And I have -24 right here. So my sine theta, 7/25. My cos theta, minus 24/25. Okay, but it asks for sine 2 theta. So I have to change that to using my identity to 2 sine theta cos theta My sine theta is 7 over 25. My cos theta is minus 24 over 25 equals. So the value then is just the multiplication of that.
I got negative 336 over 625.
That's your answer, yep. Okay. Best way to do this question is to draw that triangle first to find your three sides, because then the ratios are easy for you at that point. Sine, cos, and tan. Okay?
So, like, sorry, could you do like 6a on that page too?
Sine of negative pi over 12?
Yeah. Because that one would be similar to that number 6 on the assignment, no?
Yeah. So to get a negative value, I would take 3 pi over 12, subtract 4 pi over 12. That would give me negative 1 pi over 12. Okay? Do I?
Yeah.
Yeah. Oh, you know what though? I do. They're in fitness room.
Oh, okay.
Just grab them out of there.
Okay, thank you.
Yeah. Okay. So I have negative 3 pi over 12. So what's my identity then? So I go sine 3 pi over 12, cos 4 pi over 12, right? Subtract sine 4 pi over 12, cos 3 pi over 12, like that. So the sine of pi over 4.
Square root 2 over 2, yeah.
Right. Cos of pi over 3. Sine of pi over 3. Cos of pi over 4. And then simplify it. Root 2 minus root 6 all over 4.
Okay. And then, I'm sorry, I have another question.
Sure.
Like on page 224, when you're writing, like, say you're writing, like the values, like I got my, so like say you get like sine x for number 1a, like if their sine is equal to 0.
Yeah.
So then.
Non-permissible values.
Yeah, I know, I suck at writing them, like expressing them.
Sine x can equal 0, right?
Yeah.
That means then that x can equal 0, pi, 2 pi, 3 pi, and so on, correct?
Yeah.
So I write that as k pi, where k is an integer, because then that represents all of the pi values possible.
Okay.
All right. Now you also, in that one, you also have cos can equal 0. And cos can equal 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on.
Yeah.
So those are all odd values of pi over 2. So how do I
K
say that again?
would be pi over 2 plus pi k.
Oh, yeah, you could do it that way for sure. Yep. Plus k pi. K is an integer. Absolutely. That's one way to do it. For sure. The other way that I showed you how to do it was to make it odd. I go 2k plus 1. Pi over 2. Where k is an integer. Both of those work. Both of those are correct.
Okay.
Okay. All right. Okay, anything else out of pre-calculus?
think so.
Okay. All right, so let's go to physics now then. All right. Page 457. Actually, no, let's do this different. Let's go. I want to look at questions 1 and 2 on page 452.
Is that also on the yellow, or would that just be?
No, it's not that. I'm actually going to do the 2 practice problems on there. I'm just going to shut the, I'm going to shut this stream down on YouTube. I don't know if anybody's watching.